In this video, we're going to talk about vectors. A vector is a line with magnitude, meaning it has length, and direction, meaning it has arrows. So just like parametric equations have arrows, those are for curves. A vector is just it's a straight line, but it does have an arrow. So it has a start point. And let's say that that point is x naught, y naught, and an end point. And let's say that the end point is x1, y1. So it has a start point and an end point. Notation for vectors. There's lots of different notation that's used. A lot of times an arrow is used, and most of the time that I write it, I will write it with an arrow. But if you look in a book, oftentimes bold is used. So it'll, let's see if I can get this to write in bold. No, not really, but that's okay. But like a bold V would be used for a vector. So if you look in a book, a lot of times V is used. If we have a start point, let's say that x naught, y naught is A, and the end point, x1, y1 was B, we could write a vector as the vector from A to B. So this vector is from A to B. If we actually find that vector, and well, here's some other notation. Often that kind of a notation is used. And so if we go to find the vector from A to B, and we could do this by taking x1 minus x naught and y1 minus y naught. And what this gives us is an x direction for the x component and a y direction in the y component. Let's do an example, and I'm going to do some graphing, and this might make a little bit more sense. So if we find the vector from the point 2, 3 to the point 5, 7. So that would be, in terms of kind of my notation here, the vector of x1 minus x naught. So that's end minus start. End minus start. So end minus start. So we take the end x, which is 5, minus the start x, which is 2, which gives us 3. And then the end y, which is 7, minus the start y of 3, which would give us 4. Now if I graph this, we were starting from the point 2, 3, right there, and going to the point 3, 4, 5, and then that was 3, 4, 5, 6, 7, to the point 5, 7. So it was a line from 2, 3 to 5, 7, and it's a line from 2, 3 to 5, 7, so it has arrows. So notice that this line has length, and it has an arrow on it. Now the x direction, we found that the x direction was 3. And notice here that this moves over 1, 2, 3 spaces in the x direction. And for the y direction, we found that it moves 4 spaces. So we start at the y value of 3 and move up 4 spaces. So we move up 1, 2, 3, 4, and that gives us that 7. Right, so the vector, if I look at a vector, I could look at this vector and say, this vector moves over 3 and up 4. 3 in the x direction, 4 in the y direction. All right, the length of this vector, so this vector also has a length to it, and the magnitude or length of a vector can be found using the Pythagorean theorem. The notation for it, absolute values are used. So be careful with this, because if absolute values are around a number, it means use the positive. If absolute value marks are around a vector, it means you're going to find the magnitude. So same notation, but it means different things depending on what's on the inside. And if you have a matrix, not that we will do this in this class, but this notation is also used in linear algebra to find the determinant of a matrix. So same notation, it can be a little bit confusing. So the magnitude, if we use Pythagorean theorem, it says that 3 squared plus 4 squared is going to equal the magnitude squared. So the magnitude would be the square root of 3 squared plus 4 squared. So magnitude is always going to be just from Pythagorean theorem. And so in this case, it's going to be, that's 16 plus 9, that's 25. So that length would be 5. We could find how long that is. So in general, if we have a vector, let's see, which one do I want to use here? So let's say that if, let me use a different color here. If v is equal to the vector, I don't know, say ab, then the magnitude of v is going to equal the square root of a squared plus b squared. All right, so we have magnitude, we have how to find a vector, we've got all the notation for it. Now, with vectors, let's just say, for an example, I have the vector 2, -3. So that's a vector that goes 2 in the x direction and 1, 2, 1, 2, -3 in the y direction. So notice that I started this one at 0. Because I wasn't told what its start point was, I can start it wherever I want. So there's a vector 2, 3, and I don't know, there's another one. It has the same direction and same length, and I don't know, there's another one. I could start this vector wherever I wanted to. All of these vectors are said to be equivalent. Because if you're just given a vector, it doesn't tell you where to start and where to end. Normally we start it at 0, 0. If you want to add vectors, you add the components. I'll do an example in just a second, but I also want to do another rule here. If you multiply by a number, then you multiply all components by that same number. Okay, so let's say that, as an example, we want to take the vector 1, 2, and I want to add on to it the vector 3, -4. I'm going to add the x components, and then I will add the y components, and that will give me my resulting vector. If I add the exponents, add the x exponents, or x components, that is 3 plus 1, which is 4. And if I add the y components, that is 2 plus a -4, which is -2. And I just want to show you what this looks like graphically. if we take the vector 1, 2, 1, 2, there's that vector. And if I add on to it the vector 3, negative 4, 1, 2, 3, 1, 2, 3, 4. So there's the vector 3, negative 4. Now I want to add it on to the original vector. So I want to take this vector, and then I want to add on this vector. So I want to take the vector I have, but start from the end of the other one. And so that green vector and that black vector, notice they're the same vector, same magnitude, same direction. And what the result gives us is this end one, which is the vector 1, 2, 3, 4, down 2. It is that vector. All right, so to add vectors graphically, you place the head of one vector on the tail of the other one. So I placed I'm sorry, I think I said that wrong. So we take the head of one vector, put the tail of the other one, the one we're adding to it, onto that, and then we just connect the two. That will give us our resulting vector. All right, so to multiply by a vector, we multiply by components. So as an example, let's just do 2 times 1, 2. So 2 times 1, 2, you multiply 2 times 1, and that's 2. You multiply 2 times 2, and that's 4. So you just multiply, it's almost like distributing. You multiply every single component of that vector by 2. What this does graphically is it takes the vector 1, 2, there's that vector, but it makes it into a vector 2, 4. And so what it does is it lengthens by 2. It doubles it. If it were 1/2, it would make the vector go in half. If it is a negative, so if you multiply a vector by a negative, I'm sorry, I meant for that to be a positive 2 right there. All right, I just wanted to take the same vector but multiply it by a negative on the outside and just show you what this does graphically. 1, 2 is right there. If you multiply through by the negative, you get negative 1, negative 2. And so it flips. It basically flips the arrow. Okay, so that's adding vectors. Okay, let's look at some special vectors. And I'm hoping this video didn't just kind of do this, because I just had some technical difficulties. So hopefully you're not seeing this again. But if so, you won't see much of it again. I'll just tell you that. Okay, so the 0 vector is a special vector. It's the vector 0, 0. It has no length. It has no distance. It is basically just a single point, and it's a single point at 0. There are a couple vectors that you can create other vectors from. So these are called the standard basis vectors. And you can get other vectors from them. You can get other vectors from them. So they are the I vector, which is the vector 1 in the I direction, and 0 in the, 1 in the x direction, 0 in the y direction, or the vector j, which is 0 in the x direction and 1 in the y direction. And here's an example. We could take, we could say, let's take 2 times I plus 3 times j. So I'm just picking some random numbers there to multiply by I and add it to j. I'm showing you how this could create any other vector out there. So we would take 2 times the vector 1, 0, plus 3 times the vector 0, 1. So this would be multiplied through by the constants, 2, 0, and 0, 3, and then add those vectors together. 2 plus 0 is 2, 0 plus 3 is 3. And so notice you get the vector 2, 3 when you multiply by 2 and then 3 for the I and the j. So we could get any vector this way. And so this actually brings up a point of another notation called usually like IJ notation for a vector. So we can use the brackets, or you could use I and j out in front of the numbers. Another special vector, the unit vector. Unit vector meaning it has length of 1. So any vector of length 1, if we want to take a vector v, if we divide it by its own magnitude, then we get length 1. So this is a unit vector. So if we took the vector 2, 3, right now that vector has a length of square root of 2 squared plus 3 squared. So that would be 9 plus 4, that's root 13 right now is its length. And so in order to get the unit vector, which is in the same direction as 2, 3, same direction as 2, 3, we would take the vector 2, 3 and divide it by its magnitude. And that says unit vector right there. Looks a little weird. So a unit vector is in the same direction as the original vector. It just has a length 1, and you find it by dividing by magnitude. Okay, so I think that gives us all the background we need on vectors. But I want to look at some three-dimensional space. So, and we just need a little bit of information about three-dimensional space to kind of continue on with what we need to do. So for 3D space, usually this is done by putting the XY plane kind of out of this piece of paper and the YZ plane on the piece of paper. So usually those are the axes that are used. We can draw vectors in 3D. So as an example, we could do the vector 2, 1, negative 3. So if I were to draw this vector, I would go 2 in the x direction. So 1, 2 in the x direction. Then over from that 1 in the y direction, I'm going to use some color here. 2. So I'm going over 2 in the x direction. 1 in the y direction. So I'm going to go from that x-axis, I'm going to go over 1. So that's about 1, same as what I marked on the y-axis. So that was over a distance 1. And then I am going to go down 3 along in the z direction. So from there I'm going to go 1, 2, 3 in the z direction. And so my vector, I started from the origin, but I ended up at that point, and so there's my vector. I guess maybe those were a little bit of weird numbers because it almost looks like that vector is going straight down, but it's not quite. It's going just over a little bit in the y-axis and going forward a little bit, kind of out of the paper in the x direction. All right, but we can draw vectors in 3D, and anything we just did with all of the vectors, so finding the magnitude or finding a unit vector or adding vectors together, any of that, it works the exact same way. You just have another component to do the exact same thing to that you did with the other ones. So something else that we need to know how to do for stuff coming up is we need to know how to draw a plane. Drawing a plane in 3D. So the equation of a plane, the equation looks like ax plus by plus cz is equal to d. And this is where A, B, C, and D are numbers. And in order to draw a plane, what you really want to do is just, I usually draw intercepts. Draw intercepts and connect. Connect the points. So as an example, let's graph 2x plus 3y plus z equal to 6. All right, so now what I mean by those intercepts is where does this cross the x-axis, where does it cross the y, and where does it cross the z? So the way that we do this is we take two of the variables and set them equal to 0. Solve for the other one. So if I set x and y equal to 0, z would be 6. If I set y and z equal to 0, then x, that's the other one, so if I set y and z equal to 0, I'd have to divide by 2, so x would be 3. And if I set x and z equal to 0, I think that's the only combination I haven't done yet. So x and z equal to 0, I'd have to divide by 3, so that would give me that y is equal to 2. So if I go to graph this, x comes out of the board. I am going to put a dot where x is equal to 3 on the x-axis, where it's equal to 2 on the y-axis, and where it's equal to 6, 6 on the z-axis, and then I am going to connect those points. Right, so here is a plane. Now really it is in all dimensions, so really, you have to think of it as a piece of paper that is extending, it's extending out in all different ways. And let's do a couple more examples here, at least one more. Let's graph the plane. Let's just graph the plane z equals 2. X, y, z. So z equals 2. That's all we have. So this plane is going to be parallel to that xy. So I'm just going to draw some lines that are parallel to it and say it goes through 2. So it is a piece of paper that's sitting up at 2 and kind of going into and out of the paper from 2. There's lots more that we could do in 3 dimensions, but as far as the information that we need, at least for this class, I think I'm going to stop there.